For today, we will be discussing about acid-base equilibria, buffer system, and isotonic solutions. Now, I think you guys are familiar with this topic, especially regarding pH. So you'll be most likely aware of some of the concepts I'll be discussing. Let's say, for example, paano nakuha yung pH na total 14? Okay, di ba usually that's just simply pH plus POH. The total number of pH plus POH will always be 14. Okay, alam niyo siguro ang ibig sabihin ng pH, right? That's the power of hydrogen. And then the POH would be the power of hydroxyl groups. Okay, now class, ang POH is practically used for bases. Usually ginagamit sa mga base, pang-describe ng mga base natin. And then pH would be used for acids. Okay, pero still class, both of which, actually for base and acids, normally ginagamit lang naman talaga dyan, pang-discuss dyan would always be pH. Okay, pH is just another, parameter that we can discuss, we can use, right? So for today class, our main objectives are as follows. So at the end of the topic, so students should be able to first define acid and bases with examples, so using the different theories. This is something class na most likely you've already learned sa chemistry in org, mga Bronsted-Lowry theory, Lewis theory, Arrhenius theory, mga ganun. So we'll just have a quick recap regarding them. Okay, parang sum up lang ng mga theories na to. Then define neutralization reaction with examples. Understand pH calculations. Kasi class, though the formula for pH is very simple. Okay? Sa pinaka-common na formula nyo is pH equals negative log your hydronium ion. Okay? Yan lang naman ang formula ng pH eh. Pero class, we can do so much with this given formula. Okay? We can compute for a lot of things. Right? So yun, understand pH calculations. Next will be to define buffer equation and understand its principles and importance. Now class, very important sa atin ang buffer equation because most of the time when we prepare solutions, say for example, when we do experiments, we try to keep it class at a certain pH. Okay? We try to keep its the pH of our solutions at a certain range. And we try to avoid any changes in that pH. So hence class, to prevent the pH from changing drastically, we usually put buffers. Nag-add tayo ng buffer solution. Okay, to prevent again the drastic change in pH. Kasi as you will learn class, when the pH of a solution changes, okay, it can greatly alter the physical properties of the compounds involved, okay, in the solution. Right? It could become more water soluble, pwede siya maging mas lipid soluble, and so on and so forth. So class, you'll learn more about this as we go on. Okay, pero please know that pH again plays a vital role in the stability of our compounds, how it affects the biological systems, okay, and so on and so forth. So maraming nagagawa ang pH. Importante na intindihan natin ito. And lastly, class, to understand the significance of isotonicity in pharmaceutical preparations. So let's discuss now the first topic for today. So let's talk about class the theories of acids and bases. So basically, class, may apat lang naman na theory regarding acids and bases. So these are things that you already know. So you have the traditional theory or concept. Then we have the Arrhenius theory, Bronsted-Lowry theory, and then the Lewis theory. Okay, so sa traditional class, ito lang naman yung, this is the easiest theory that we have. Okay, sabi natin, ano bang acid? An acid is any substance that converts blue litmus paper to red, right? And its pH is usually less than 7. So sabi natin, 7 being the neutral pH. Okay? It's the neutral pH. So sabi natin, generally, all acids are sour, and they react with bases to form salts and water. So meaning class, whenever neutralization reaction occurs, okay, when a acid combines with a base, so ito lagi sinasabi natin, when an acid combines to a base, it always forms a salt plus a byproduct of water. Okay, so generally, yun yung neutralization reaction nangyayari. Okay, pero of course, class, that's not always true all the time. Right? There are some neutralization reaction class where actually one of the byproducts is not just water, but also carbon dioxide. Say, for example, the neutralization reaction within the with the use of bicarbonates, say for example. Okay, mga bicarbs natin class, hindi lang salt and water ang pinoproduce doon. Isa sa mga byproduct nun class will be carbon dioxide. Okay, kaya nga, di ba, pag gagamit ka ng bicarbonate, say, for example, use a bicarbonate as an antacid, one of the major side effects class would be flatulence. Okay? Tawag ito, flatulence. Mag-uutot-utot ka. You'll be gassy. Okay? You'll become gassy. So, didighay ka ng didighay. Tapos, syempre, pag sa kabilang side naman siya lalabas, di uutot ka ng uutot. right? So that's another byproduct of neutralization reaction. Pero ang general theory is basta salt and water ang napoproduce. Pero again, it's not always the case. Okay? Sometimes a byproduct can also be carbon dioxide. Okay? So pwedeng maraming byproduct ang neutralization reaction. So pero the basic again, the most basic reaction will always be this one. That's the most basic. Okay? Kaya nga class, pansinin ninyo, Kreml S halimbawa, kadalasan dinadagdagan ng simeticone. Okay, I think you're familiar with simeticone. Are you familiar with the effects of simeticone? Familiar ba kayo? Kreml S. Kaya nga may S yun eh. Kreml S. Aluminum hydroxide. Oops. Plus magnesium hydroxide plus simeticone. Any idea what the simeticone is for? Yes, anti-flatulent. Yes, very good, Mr. Reyes. Okay, it's actually one of the one of the chemical substances class that prevents the formation of too much gas. Okay, during the neutralization reaction. Para hindi ka naman kabagin, kumbaga. Okay, kasi minsan din yung pananakit ng tiyan natin dahil sa kabag. Okay? So kaya ang ginagawa kasi sa simeticone is it neutralizes the formation of too much air within the GI tract para hindi sumakit. Okay? So yun yun. Alam niyo na siguro reason ba't kino-combine ng aluminum hydroxide and magnesium hydroxide, right? Tama nga ba? Are you familiar with why we combine aluminum hydroxide with magnesium hydroxide? Kasi if you think about it, sir, di ba both are bases, both can neutralize acids. Why do we have to combine them? So hindi pa not yet familiar. Okay? One drug class, yes, Mr. Kian?
Yes, sir, not familiar pa po, sir.
Hindi pa familiar. Okay. Okay, let me give you a clue. One of the drugs here, class, ang side effect niya is constipation. The other one is diarrhea. Sino sa dalawang yan ang nagkakos ng constipation? Kasi tingin sa dalawa, aluminum hydroxide versus magnesium hydroxide. Who among them has a side effect of constipation?
Aluminum hydroxide, sir.
Very good. Aluminum hydroxide class causes constipation. Magnesium hydroxide, on the other hand, causes diarrhea. Okay? Kaya sa pinag-combine para mag-cancel out yung effects nila. Make sense? Kasi if I give you aluminum hydroxide lang, ang tendency is mawawala nga yung kabag mo, magko-constipate ka naman. Bigyan kita ng magnesium hydroxide, mawawala nga yung acidity, hyperacidity pa lang, tinatanggal nun. Bigyan kita ng magnesium hydroxide lang, okay? Mawawala nga yung inyong hyperacidity, pero it will lead to diarrhea naman. Just so you know, class, magnesium hydroxide is also used as a, they call this, as a laxative. Okay, you can use this as a laxative. Okay, yung pure form niya. Pero again, in most preparations class for hyperacidity, kino-combine natin si mag hydroxide sa si aluminum hydroxide. Right? Now, what about for bases? Sabi natin, it's just the opposite of what acids do. So, bases naman on the other hand converts red litmus paper to blue, pH having, the pH is greater than 7 most of the time. Its taste is bitter. Okay? It reacts with acids to form salts and water. And an example of which would be sodium hydroxide, the most popular one. Now, as for the Arrhenius theory naman class in 1884, okay, they stated, okay, the theory, the Arrhenius theory, wherein this theory defines the acids and bases according to their formation of ions when dissolved in water. Now, class, again, ang principal class ni Arrhenius, okay, is that it always involves the reaction of an acid and a base in water. Okay, kasi you'll find out, class, that's one of the limitations of this type of theory. Kasi ang explanation niya lang will always involve putting an acid in water or putting a base in water. Kasi generally, class, ang assumption of theory na to is that whenever an acid or a base, okay, is exposed to water, right, it starts to dissociate into its ions. Sabi natin, di ba, ions, dalawa lang naman yan eh, positive or negative ions. Okay, so it has the ability to dissociate in water. Okay? Now, according to Arrhenius, right, an acid is a substance that can release hydrogen ion when dissolved in water. So meaning, a substance is an acid, okay, once it is exposed in water and it starts releasing hydronium ions or hydrogen ions. Okay, it starts releasing hydrogen ions. As you all know, class, the charge of hydrogen ions would always be positive. Kasi nga, class, acids are, well, actually, there's another theory, maya-maya pa to sa ating Bronsted-Lowry. Okay, pero sabi na doon kasi, class, acids donates protons. And as you all know, ang charge ni proton is positive. Okay? So meaning class, acids will always have an excess proton. Okay? So si base naman class, on the other hand, ano naman meron kay base? Si base naman class, kapag dinesolve sa tubig, ang nire-release niya raw, instead of hydrogen ions, it releases hydroxyl ions. Okay? OH, OH. Okay, wherein class, ang charge niya would be negative. So meaning, once a base daw is placed in water, it's always going to release hydroxyl ions daw, which is negatively charged. Now question, ano naman ang excess ng mga bases? Bases have an excess of protons or electrons? Very
Electrons po.
Alright, very good guys. So alam nyo to. So bases have an excess of electrons. So therefore class, bases are proton acceptors. Gets? They accept protons. Kasi ang excess sa kanila is electrons. Okay? On the other hand, acids naman are proton donors. Right? Now that's mainly based on the Bronsted-Lowry theory. Okay? In terms of protons. Now in terms of electrons, sino ang nagdo-donate? Okay,
Si base po.
Very good. Bases class donates electrons, while on the other hand, acids accepts electrons. Make sense? Okay, so at least I'm happy familiar na sa inyo yung concept na to. Okay, so gusto tayo doon. Okay? So yun siya. Pero again class, pagdating sa bonding ng mga molecules natin, ang kinoconsider lang natin would be of course the electrons, hindi yung protons. Okay? The reactions, the sharing of electrons, the electron cloud model, blah blah blah. Okay, sa bonding ng mga molecules natin or elements. Okay, pero in terms of acids and bases, so yun siya. Now, the neutralization reaction class based on the Arrhenius theory would simply say that when acid reacts to a base, okay, it starts to form salt and water. Okay, such as when a hydrochloric acid reacts to sodium hydroxide. So, sodium hydroxide is the base. Okay, hydrochloric acid obviously is the acid, and the form ang magiging resulting product class would be a salt and water. So basically, that's that. Okay, that's the traditional concept regarding acids and bases. Okay. Now, according naman to Arrhenius theory, neutralization as the process in which hydrogen ion and hydroxyl ions combine to form an unionized molecule or water. Okay. Now, class, ang sabi niya dito is an unionized molecule. Na hindi ibig sabihin, basta ang ibig sabihin lang ng unionized na to. Okay? Kasi may babanggitin ako mamayang regarding ionized and unionized. Pero ang sinasabi niya lang dito is unionized meaning neutral charge. Oops, neutral charge. Kasi kung titingnan nyo class, ang sodium chloride, neutral ang charge niya, right? It's neutral. It's neither positive nor negative. Kasi kanina yung combination ng sodium hydroxide, okay, and hydrochloric acid, kitang-kita nyo yung charge nilang dalawa. Sodium hydroxide is a base, -1 siya. Okay, si hydrochloric acid may excess protons, so positive yung charge niya. So this is a base and acid. Once combined, they form a salt which is neutral and we say it's unionized. Hindi siya naghiwalay. Hindi naghiwalay into its charges. Now, because of course, pag nilagay ko ang sodium chloride sa tubig, pwede siya maghiwalay to its sodium and chlorine components, which makes them ionized. Okay, which converts them into ions. All right? Pero basta ngayon ang sinasabi lang dito is to form a neutral or an unionized molecule. Neutral. Baga hindi define yung kanyang charge, which is of course sodium chloride. So, ayan. Now, some of the limitations because of the Arrhenius theory is that in all of its explanation, kailangan lagi may tubig na involved. Okay? Not all the time, class, when an acid reacts to a base, there's always water. Acid and bases can still react kahit walang tubig na involved. Right? So, isa yun sa mga limitations ng Arrhenius theory. Then, second would be not to explain the acidity or basicity of non-aqueous solvents such as benzene. Okay? Kasi class, ang madalas na binabanggit sa Arrhenius theory is simply the acidity or basicity of aqueous solvents. Okay? Or aqueous solutions. Benzene is a non-aqueous solution. So how do I explain the acidity and basicity of that? Or the pH of benzene using the Arrhenius theory. So, syempre, yung isa sa mga limitations na naman ni Arrhenius theory. Or the basicity of ammonia. Kasi tingnan nyo kasi, ammonia is NH4. Tama? It's NH4. Ang sabi sa Arrhenius theory, ano daw mga bases? Yung mga may OH. Kasi ammonia, wala namang OH. Correct? Or boron trifluoride or aluminum trichloride. Okay? Si boron trifluoride sa aluminum trichloride, these are acids, but they don't have hydrogen ions, right? Okay? Kaya hindi kaya i-explain ni Arrhenius theory yan. So again, it's another limitation of the Arrhenius theory. So what about acidity of the oxides of the P block elements such as carbon dioxide? It's not explained. Just so you know, class, carbon dioxide is acidic. Okay? Or the basicity of oxides of the S block elements such as sodium oxide. Okay? Sodium oxide, class, is ano naman, obviously it's basic. Okay? And the neutralization without absence of solvent is not explained as well. Okay, so maraming limitations ang Arrhenius theory. Kaya nga lumabas yung iba pang mga theories regarding pH. Okay, and then here comes now Bronsted-Lowry theory. Kaya sinabi ni Bronsted at saka ni Johann Nicolaus Bronsted at saka ni Thomas Lowry, okay, they proposed a theory that acid is a substance which donates protons. Okay, yun. Kaya nga laging may positive charge ang ating mga acids, while the base, on the other hand, class, accepts protons. Kaya negative lagi ang charge niya. So meaning, class, whatever the chemical formula of a molecule is, basta an acid combines with a base, okay, especially for weak acids ito, okay, especially for weak acids, they always, class, form a conjugate base and a hydronium ion. Alright? Or, for a weak base, halimbawa, provided again the water yung aking pinaka solvent, alright? When a weak base, class, combines with an acid, let's say for example water ulit, okay? Ang mag-form niya naman, class, is a conjugate acid and a hydroxide ion. Now, you might be wondering nga pala sir, but pag sinabi niyong tubig, it can be base and an acid? Okay, baka tanungin niyo ako tungkol dyan. Just so you know, class, amphoteric kasi si water. When we say amphoteric, class, it's a type of solvent that can exist as an acid and as a base. Depende kung ano ang solute na nag-dissolve sa kanya. Okay? So again, class, water is amphoteric. Amphoteric, meaning it can exist as either a base or an acid. Okay, naalala ko tuloy ang joke sa amin dito ng prof namin dati. Okay, sabi raw nila, bisexual daw ang water. Pwede sa lalaki, pwede sa babae. Okay, parang ganyan yung niya. Pero amphoteric siya. So meaning, it can either work as a base or as an acid. Yun lang. Okay? Kaya, water ang ginamit natin example dito. So class, ang acid natin, right? So acid plus a base, which is water, combine them, you form a conjugate base and an hydronium ion. Okay? While on the other hand, a base, okay, combined with an acid will form a conjugate acid and a hydroxide ion. Now, sir, ano bang pinagsasabi niyong conjugate acid and conjugate base? Diba, baka tanungin niyo rin yan. Naintindihan niyo ba yung concept ng conjugate acid and conjugate base? Naintindihan niyo ito noon? Were you able to understand this? Okay?
Medyo po, sir.
Medyo, okay. Kasi ako nung college ako, hindi ko talaga ito naintindihan. Right? Basta sabi ko, bahala na kung ano yung conjugate acid, conjugate base. I never understood this when I was in physical pharmacy back then. Sabi ko, hindi ko alam kung paano ako nakapasa doon pero napasa naman. Pero anyway, class, ito lang kailangan nyo tandaan. Ang conjugate base, di ba, mag-umpisa ka as an acid. You start as an acid. Sabi natin, si acid is a proton donor. Right? Acid is a proton donor. Now, combine that to a base. Sabi natin, ang gagawin ni acid is, idodonate niya yung kanyang protons. Tama? I-donate niya yung protons niya kay base, right? So, yung protons ko, lipat sa kanya. Ngayon, dahil nag-donate na si acid ng base, binigay niya na yung kanyang proton, mababago si acid. Kasi nagbigay siya ng protons Mababago siya. Kasi pag nagbago siya, hindi na siya yung regular acid na. Hindi na siya yung regular acid lang. Ang tawag na sa kanya is a conjugate acid. Okay? Sorry, a conjugate base. Ano ba yan? Hindi siya conjugate acid, He now becomes a conjugate base. Okay, magiging conjugate base na siya. Bakit? Kasi binigay niya na yung protons niya. Kumbaga, nag-donate na siya ng proton. So, hindi na siya acid. Kasi di ba sabi natin, an acid is someone with excess protons. Right? An acid is someone with excess protons. I just gave my protons away. So, I'm no longer an acid. I became now a conjugate base. Okay? Kumbaga, technically, hindi pa naman siya base na base kasi hindi pa nagkukulang yung acid yung kanyang protons. May protons pa naman siya. Enough pa yun. Kaya nag-donate na siya ng excess niya. Pero it becomes now a conjugate base. Sabi nga natin, class, a conjugate base is a species that remains after an acid donates its hydrogen ions or its protons. Okay? What about the conjugate acid? Okay? A conjugate acid naman, class, is what forms after a base accepts hydronium ions. Okay? Very good. Okay, so it's vice versa. So, ganun siya. Okay? Kaya kasi mamaya makikita yung sa equation natin. Okay, let's say for now, once I start discussing, class, the Henderson-Hasselbalch equation, which is used for buffers, okay, makikita nyo dyan, conjugate base acid. Conjugate base over acid, or acid over conjugate base. Kaya conjugate acid over base. And so on and so forth. So, para alam nyo lang, so that I know na alam nyo yung concept between conjugate base and conjugate acid. Now, another thing, class, na titingnan nyo rin dito is, okay, kadalasan, kapag sa isang equation, may nakita kang, say for example, a chemical reaction between an acid and a base. Tapos nakita mo yung ang magiging product niya, okay, ang magiging product niya, class, may makikita ka dyan chemical, may negative sign. Okay? Tapos isang chemical dyan, nakita mo H3O, hydronium ion, or anything na basta may hydrogen, tapos positive ang sign. Okay? Anything, class, that contains a negative sign is called the conjugate base. Okay? Yun yung conjugate base natin. Okay? Sige, mamaya i-explain ko to in more details once I have an example na. Pero just remember, class, a conjugate base oftentimes has a negative representation in it because it started to donate na its protons to the base. Okay? A conjugate base is what remains to an acid once it starts donating its protons. Yun lang yung gusto ko maalala nyo dito. Alright? Okay, ito kaya sinabi ko sa inyo, amphoteric. Okay? It's a species that can act as an acid or a base. And a good example of this would be water. Right? Now, what about the Lewis theory? Si Lewis naman, so kaya si Bronsted-Lowry, ang in-explain niya yung donation of protons. Okay? Now, sa Lewis theory naman, ano sinabi naman dito? Okay, it proposed a theory in terms of the chemical structure. Now, acid is a molecule or an ion that accepts a lone pair of electrons. So, meaning, any chemical that can accept lone pair of electrons now can be considered as an acid. Okay? While a base, on the other hand, is a molecule and ion that donates lone pair of electrons. Okay? So basically, class, ang gusto lang sabihin ni Lewis theory is anything that is positively charged has the potential to become an acid. Okay? Anything that is negatively charged has the potential of becoming a base. Potential of becoming a base. So are we clear with that? Kasi for example, cyanide, chlorine, okay, OH, hydroxyl ions, so negatively charged, they can donate electrons, so therefore they have the potential to become bases. Right? Okay. Now let's talk about, class, the extent of ionizations of weak acids and weak bases. Now most of the time kasi, class, in your general chemistry, kung saan yung unang, I think, okay, correct me if I'm wrong, I think unang yung narinig ang concept ng pH sa chemistry, tama? Okay. So, yun yung unang na-inform about what pH is all about. Now, class, ang examples doon karamihan are strong acids and strong bases. Okay, let's say, for example, sodium hydroxide. Okay, hydrochloric acid, sulfuric acid, di ba? Strong acids and strong bases yon. Meaning, ang pinagkaiba kasi, class, ng strong acids and strong electrolytes, so weak electrolytes is, okay, strong electrolytes. Tapos, versus weak electrolytes. Okay? Ito kasi, class, ang strong electrolytes always undergoes complete dissociation. Ang weak electrolytes only undergoes what we call a partial dissociation. Anong ibig sabihin nun, sir? You might be wondering. Alam naman natin kasi ba, ang electrolytes, ang acids and base natin, either positive or negative. So meaning may ions siya. Right? They are ions. Okay? Now, class, if you put kasi a strong electrolyte in water, it will undergo complete dissociation, meaning it's going to separate into its positive and negative components. That's what we mean, class, when we say dissociation. Okay, it's going to separate into its conjugate acid and its acid and conjugate base. Right? Completely. Am I clear with that? Complete yung separation niya. So meaning 1:1 talaga yan. Okay, 1:1 yung separation nila. Unlike that of a weak electrolyte class, they only undergo partial dissociation. At ang dissociation yan will strictly depend on the pH of the solution it's being dissolved in. So meaning, class, say for example, water. Alam natin, water is amphoteric. Pero class, ang dissociation ng weak electrolyte will be very dependent on the pH, on the current existing pH of the water. Pag strong electrolyte yan, walang pakialam yan kung ano man ang pH ng iyong water. Basta water yan, it's going to completely dissociate into its positive and negative charges. Pero if it's a weak electrolyte class, it will only undergo partial dissociation. It's not gonna completely dissociate. Does that make sense? Okay, I hope I'm making sense ka. Ang pag-dissociate yun, class, ito yun, no? Ano yun? Ayan. Pag-dissociate niya ito, its conjugate base and its hydronium ion. Okay? Pag yan ay strong electrolyte class, completely separated itong dalawang to. Okay? Maghihiwalay talaga yung dalawang yan. Completely. Pero if it's a weak electrolyte class, ang tendency is hindi complete yung separation ng conjugate base sa kanyang acid. Okay, sa kanyang hydronium ion. Alright? If it's an acid. Yun lang. Ang gusto kong maalala nyo dito. Again, hindi complete ang dissociation pag weak electrolyte, complete pag strong electrolyte. Kasi mamaya ka sa mga computations natin, magugulat kayo, okay? May mga computations na hindi ko na kailangan, basta mamaya na lang. Okay? Makikita nyo kasi mas madaling mag-compute pag strong electrolyte yung aking substance. Mas mahirap mag-compute kapag weak electrolytes ang gamit ko. Eh class, guess what? Majority of our drugs in the markets are all weak electrolytes. Okay? Strong electrolytes class are only used in laboratories. Right? So if I'm going to distinguish if I'm going to determine the pH of my drugs, okay, I can expect that my drug is a weak electrolyte, and which actually makes my computations a lot more difficult in a sense. Okay? Mas complicated kasi ang computation pag weak electrolyte kumpara sa isang strong electrolyte. Okay? So mamaya makikita nyo. Right? Okay, so extent of ionization. So sabi nga natin, it greatly depends on the pKa of your acid or base and then the pH of your solution. Kung saan mo tutunawin yung acid or base ninyo. Before I forget any further, are you familiar with the concept of pKa? pKa class is known as your dissociation constant. May idea ba kayo kung ano ang dissociation constant? Familiar? Is the term familiar? Familiar ba?
Familiar po, sir.
Okay, familiar naman. Pero hindi lang naintindihan siguro. Hindi medyo naintindihan. Or hindi pa kasi na-apply eh. Tama? Hindi pa masyado na-apply. Kaya hindi nyo pa na-appreciate kung ano yung pKa. Now, class, ito lang tatandaan nyo dito. A pKa class is inherent in a chemical substance. Meaning, whatever your chemical is, in its pure form, its pKa will always be constant. Okay? Ano ba sir ang ibig sabihin pag sinabi ko dissociation constant? Ang pKa class will tell you at what pH will this substance completely dissociate into its positive and negative charges, into its conjugate base and acid. Are we clear? Ulitin ko. Ang pKa class, kaya siya tawag na dissociation constant, sinasabi lang ng pKa sa'yo kung kailan magdi-dissociate ang isang acid or base na pag nilagay mo sa isang solution, anong pH dapat yung solution na yon para mag-completely dissociate siya into its positive and negative charges, into its conjugate base and hydronium ion. So halimbawa, bigyan ko yung example. Wait lang. Sir, ano nga ba pKa nun? Let me just check. Okay, baka para actually ibibigay ko sa inyo example. Okay? Ano bang pKa ng aspirin? I forgot. Aspirin. Okay, it's 2.97. So let's say class aspirin has a pKa of 2.97. It's a pKa of 2.97. Aspirin. Okay? Now class, if I expose aspirin, ito kunwari, this is water. Kunwari lang water that I made na ang pH is 2.97. Okay? Pag nilagay ko si aspirin which is a weak acid, It's a weak acid. Okay? Pag nilagay ko siya class dito sa tubig na to, whose pH is 2.97, ano mangyayari sa aspirin ko? It will completely dissociate. Are we clear? Kasi, andoon ako sa kanyang dissociation constant, which is 2.97. Naintindihan ba, class? Ibig sabihin, my aspirin will start to dissociate into its conjugate base and hydronium ions completely. Dito maghihiwa-hiwalay na yan, lahat ng charges niya. Completely. Are we clear? Kaya nga sinabi ko sa inyo, di ba, ang hirap, class, the problem with weak electrolytes is, it doesn't completely dissociate in water. Kailangan i-adjust mo pa ang pH ng water if you want it to completely dissociate. Again, unlike that of strong electrolytes, kahit ano pa ang pH ng tubig mo, ihulog mo siya dyan, magko-completely dissociate yan. Are we clear? Which makes weak electrolytes, class, a lot more complicated to handle. Okay, mas komplikado siyang i-handle. Pero at least now, nag-gets yun na. Okay? Kaya class, this is one way of assessing the purity of your substance. If you're a quality control, if you are doing quality assurance class of certain acids and bases, usually, titingnan mo kung ano ang pKa ng substance mo. Ikaw magte-test mismo niyan. Tingnan mo kung magdi-dissociate siya completely sa pH na to. Pag nag-dissociate siya, pure yung substance ko. Kasi hindi na-alter yung kanyang pKa. Are we good? Okay. So again, pKa, extent of ionization depends mostly on the pKa of your substance and the pH of the solution. And this solution is most often water. Kadalasan tubig yan. Now, ionized form is more polar, thus more water-soluble than non-ionized forms. Okay? Kasi class, when you expose an acid in a solution of varying pH, okay, sabi nga natin, di ba, magsiseparate siya into its charges. Okay? Now, it's going to separate class into either its ionized versus unionized form. Okay? Ionized versus unionized form. Mamaya, pakita ko lang sa inyo to. Right? So, ionization form imparts good water solubility. So, meaning if majority of my acid will exist in its ionized state, okay, then that would mean, class, that it's going to be more water soluble. Right? It's going to be more water soluble. Now, if my acid, if exposed in a certain solvent under certain pH, becomes unionized, then it becomes more lipid soluble and hence can easily cross the cell membrane. Okay? Sige. Let me give you an example para mas maintindihan natin. Okay? Let's say, class, this is, the blue part here is the intestines. Okay? Alam niyo naman, di ba, ang intestines natin is basic by nature, right? The environment of the intestines is basic. On top of our intestines is the stomach. And generally, class, the stomach is acidic, correct? It's generally acidic. Okay? Now, what do you think, class, will happen if I have here a weak acid substance? Isipin nyo to, ha? Weak acid yung substance ko. Weak acid. Now, class, in-expose ko sa isang basic environment. What kind of reaction will you expect? Ano mangyayari sa kanya? What kind of reaction? There's an acid.
Neutralization po.
Very good. Magkakaroon tayo ng neutralization reaction here, right? Okay, wherein the acids and the base will start to combine. Okay? And hence, class, what is formed? Sabi natin, generally, ang output ng
Salt
isang
plus
Salt and water.
Very good. Okay, what we form here, class, is salt. Yun na lang. Doon na tayo. Salt. Hama na yung water. Byproduct na yan. Okay. Now, salt kasi, class, diba sabi ko sa inyo, it will form, sabi na natin, the combination of acid and base will form an unionized molecule, meaning wala siyang charge. Technically, class, salt doesn't really have a charge. But if it's exposed to water, if dissolved in water, it can easily separate into its positive and negative charges, right? A salt, sodium chloride, if exposed in water, will separate into its positive, which is sodium. Kunwari lang muna, sodium and chlorine. Positive and negative. So these are ions, correct? Generally, these are ions. So class, if a weak acid is combining with a basic environment, then what I form is a salt, and salts are can create ions, so therefore, they are considered to be ionized. Okay? So class, yung weak acid ko na to na substance becomes ionized in basic environment. Does that make sense? Does that make sense? Okay, ulitin ko lang class ha. When a weak acid drug is exposed in the basic environment of my intestines, or for whatever basic environment that would be, okay, acid ang drug ko, base ang environment. So pag nag-combine, ang form ko is a salt. And a salt class is considered to be ionized. It can easily separate into its positive and negative charges. Now, class 1, the properties kasi of ionized compounds, yung drug ko from weak acid biglang naging ionized kasi na-neutralize siya. Okay? Is that it's more water soluble. Does that make sense? Kasi tanungin ko kayo, class, saan ba natutunaw ang asin? Where does salt dissolve? Saan ba natutunaw ang asin? Sa tubig o sa mantika? Yun na lang.
Sa tubig po.
Tubig lang siya natutunaw. Have you ever tried putting salt in oil? Nagpiprito ba kayo ng isda? Nagawa niyo na ba magprito ng isda? Okay, sa mga hindi pa na-try yun, sige, okay lang. Okay? Pero kasi pag nagprito ka ng isda, di ba? Bubudburan mo muna ng asin yung isda bago mo siya iprito para may lasa-lasa naman siya ng konti. Lalo na pag tilapia. Kaya hindi ganun kamalasin yung laman niya eh. So, bubudburan mo siya ng asin. Ngayon, class, pagka-prito mo, tanggalin mo yung isda, class, buo pa rin yung asin kahit na-prito mo na. Have you noticed that? Okay? Yung asin na binudbud mo sa iyong sa iyong isda, buo pa rin kahit nilagyan mo pa ng heat yan, class, because salt never dissolves in water. Okay? It does not separate into its ions. Nagse-separate lang siya into its ions sa tubig. Okay? So therefore, class, a salt is water soluble. So if my weak acid is exposed to a basic environment, it becomes a salt which makes it water soluble. Nagets? And if this is happening, class, inside my body, ang fate ng gamot na to, right? Ang sinasabi kong fate dito, ang kanyang kapalaran. Ang kapalaran ng gamot, class, that exists in its ionized state is that it's easily excreted. Are we clear? Ang kapalaran ng gamot, class, that exists in its ionized state inside my body is that it will be excreted. Kasi water soluble siya. Mabilis siyang sasama sa urine. Okay, dahil saan ba gawa ang wiwi natin? Gawa ba ito sa mantika? Our urine, class, not made of oil, it's mostly made up of water. At dahil water soluble na yung gamot ko, nag-exist siya in its salt form, okay, so mabilis na lang siya sasama sa urine, mas mabilis na excrete. Kaya tingnan nyo, class, whenever we assess for the amount of drug leaving the body, ano madalas at titingnan ko? Am I looking at your feces? If I'm going to determine the amount of drug leaving your body, most of the time, class, I'll be looking at your urine. Sa wiwi tayo titingin. Okay? Kasi dyan lang naman sasama yung mga ang gamot naging water soluble na. Right? Okay, so what about class A, for example, a weak-based drug exposed in the acid environments of the stomach. So weak-based ang gamot ko, acid ang stomach ko, ano mangyayari sa gamot ko? Will it exist in its ionized or unionized state? Okay, anyone? Ionized ba siya? Magiging ionized or unionized siya? Okay? Ulitin ko. Weak-based ang gamot. Acid ang stomach ko.
Ionized pa rin, sir.
Very good. Okay, class, it's still going to exist in its ionized state. Kasi nag-undergo siya ng neutralization reaction. So again, it makes it more water soluble. Make sense? So ano ang fate ng gamot kong ito? Inside my body. Ma-absorb, ma-excrete.
Ma-absorb po.
Technically, well, yes, actually, ma-absorb talaga to. Some of it will be absorbed. Pero majority would be, yun na lang, sorry. Okay, majority would be excreted. Kasi again, di ba sabi ko sa inyo kanina, pag water soluble, ang drug molecule ko, most likely, class, dahil water soluble siya, mas mabilis siyang sasama sa wiwi. Okay, sa urine, which is mostly made up of water. Are we good? Okay. Pero class, you learn more about this kasi sa biopharmaceutics. Okay? Generally, sabi natin, for a drug to be absorbed into the blood, it has to be water soluble. Kasi sabi natin, tubig ang dugo natin. Pero class, for a drug to be absorbed into the cell, okay, which is mainly covered with cell membrane, yung cell membrane kasi natin is lipid, kailangan unionized yung gamot ko. So, maliwanag ba tayo doon? Okay. So, yan. Yun muna yung natin. Kasi class, maniwala kayo sa hindi. Sa board exams, class, we've experienced one board exams wherein siguro 15 to 20 questions, ang tanong lang, will the drug exist in its ionized or unionized state? Bibigay lang sa yung pH ng gamot. Okay, so ikaw magde-decide. Ito yung pKa ng gamot ko, ito yung pH ng solution, ano mangyayari sa kanya, bla bla bla. Ganon. Okay? So wait lang, erase ko muna pala to. Eraser. Okay. I hope that makes sense. Okay? So basta tandaan nyo muna ha, for now, kung pH lang yung pag-uusapan, pH lang ha, wala mo nang involvement ng other factors sa biopharm nyo na pag-aralan yon. Okay? Kung pH lang ang involved, right? If a drug class exists in its ionized state, salt form, ang kanyang expected fate is to be excreted. Alright? To be excreted. Pero again, class, there are so many factors pa affecting drug absorption. pH is just one of the so many. Right? Okay. Ito ngayon, class. Next na question ko. I have here a weak-base drug in the basic environment of my intestines. Pag pinagsama ko sila, weak-base ang gamot ko, basic ang environment ko, anong mangyayari? May mangyayari ba o wala?
Non-ionized po.
Okay, strong base. Actually, hindi, pwedeng kasi base-base. They strong base. Tama. Pwede yun, no? Pero, ang mangyayari dyan, classes, wala. Walang mangyayari sa kanila. Okay? It will exist in its unionized state. Bakit siya unionized? Kasi hindi siya nag-dissociate. Nagets? Kasi base siya eh. In-expose mo ulit sa isang basic environment. Base sa base. Walang mangyayari sa kanila. So, they won't dissociate. So, therefore, they remain unionized. Nagets? Si salt kanina, kaya siya naging ionized kasi maghihiwalay ang kanyang positive and negative charges once exposed to water. Correct? Okay. Ito, base sa base lang eh. Base. So, base, super base. Okay? Base, ano lang yun? Basta wala mangyayari. Okay? Base sa base eh. Alright? So, I hope that makes sense, class. Walang mangyayari sa kanila, so therefore, they will remain unionized. Okay? At class, ang lagi natin sinasabi dito, kung ang ionized, if ionized equals water soluble, ang unionized is equal to lipid soluble. Are we clear? Now, ibig sabihin, class, if my drug is exposed into the intestines, into the basic pH of my intestines, a weak-based drug is exposed to the basic pH of my intestines, okay, it's going to exist in its unionized state. At dahil siya ay unionized, okay, it's gonna be lipid soluble. At kapag lipid soluble siya, ano expected ko? Absorb, excrete.
Absorb po.
Very
Absorb
good.
po.
Etong absorb. Please take note of this. Absorb into the cell. Into the cell. Alright? Am I clear with this? I want to clarify this, class. Kasi you'll be reading a lot of things, class, na magsasabing, for a drug to be absorbed, it must be water soluble. Okay? You'll see a lot of literature saying that. And they are correct in that sense. Kasi, pag sinabi ng class, a drug must be water soluble for it to be absorbed, okay, they're referring, class, to the absorption of drug into your bloodstream. Are we clear? Very good. So, ulitin ko for a drug to be absorbed into the blood, it must be water soluble. Makes sense, kasi tubig ang dugo ko. Pero for a drug to enter into the cell, para mag-create ng response, kailangan siya ay lipid soluble. Okay, lipid soluble. So, maliwanag ko tayo doon? Kaya nga, class, ang ganda ng pagkagawa ng gamot. Kasi ang mga gamot natin ay weak electrolytes. They partially dissociate. Partial lang sila mag-dissociate. Ibig sabihin, some parts of my drug makes it water soluble depending on the pH, while other parts of the drug makes them lipid soluble because they don't completely dissociate. Does that make sense? Okay.
Yes po, sir.
Kinda. Okay, good. Okay, I hope I'm naipapaliwanag ko to, class, in a manner na madaling maintindihan. Okay? Basta tandaan nyo lang to, class, for a drug to be absorbed into the body, yes, it must be water soluble. Pero for it to cross into the cell membrane to create a response, it must be lipid soluble. Very good. Okay. Pero baka sabihin nyo, pag puro water soluble ang gamot, kung wala na siyang pag-asang ma-absorb sa cell. May pag-asa pa yan. Alright? Pwede siya mag-undergo ng convective transport mechanisms. It will be using the small pores within the cell to cross the cell membrane. You'll learn more about that class in BioFar. Okay, kung mga mechanisms of absorption in the cell or in the body. Pero generally, pag pH lang ang pag-uusapan, pH lang, ang topic natin for today, okay, pag unionized, absorbed into the cell. Alright? So hence class, if I have a weak acid drug, in the acid environment of my stomach, it will exist again in its unionized state. And it's gonna be lipid soluble. And if it's lipid soluble, ano ang fate ng gamot na ito? Absorb, excrete. Absorb. Okay. Very good. Right? So it's gonna be absorbed. So class, ang principle behind this class is what we call the ion trapping theory. Okay, wherein if my substance class exists in its ionized state, say for example, acid, weak acid na exposed sa basic environment ng intestines, naging ionized siya, naging salt. So dahil water soluble siya class, saan ulit gawa ang cell membrane? Okay, saan to gawa?
Lipid po.
Lipids po, phospholipid.
It's a phospholipid. This is the lipid bilayer membrane. Okay, remember that. Now class, dahil water soluble siya, lipid ito, anong expected reaction ko? Okay, will there be attraction or repulsion? Okay.
Repulsion.
Repulsion.
Very good. It's gonna repel this. Kasi nga, lipid yung cell membrane ko. So therefore, an ionized substance cannot cross the cell membrane. Pag hindi siya nag-cross ng cell membrane, it won't be able to trigger the response needed. So ano na lang ang gagawin sa substance na to? Sabi natin, it's repelled by the lipid membrane. So therefore, ang fate ng gamot na to, okay, is simply it's going to be excreted. Okay, tatapon na lang siya. Sasama na lang siya sa urine. Sabi natin, go with urine. Okay. What about class for a substance that exists in its unionized state? It's lipid soluble. So sabi natin, di ba sa solubility, di ba isa sa mga basic concepts natin in solubility is that like dissolves like. Correct? Excuse me. Unionized, lipid soluble siya. Papasok sa lipid membrane, so like. Tatagos lang siya. Okay? At pag tumagos yan, pwede siya mag-bind sa receptors within the cell to create a response. So therefore, class, we say that unionized substances can easily enter the lipid membrane. Okay? It easily enter the lipid membrane, and therefore, it's generally considered to be absorbed. Does that make sense? Okay. So class, mamaya pag-usapan ko to in more details. Okay, the Henderson-Hasselbalch equation, especially in buffer. Pero class, gusto ko ipakita sa inyo kung ano ba itsura ng formula na to. For the Henderson-Hasselbalch equation kasi class, it gives you the relationship between ionized and unionized species existing once a weak electrolyte is exposed to a pH of a solvent. Into a solvent. Sabi ko sa iyo, di ba, hindi siya completely nag-dissociate, right? So again, the complete dissociation class of your weak electrolyte only happens once pH is equal to pKa. Okay? Once the pH is equal to pKa class, pH nung solvent or nung solution, saka pKa nung drug. Pag equal yan, karoon ng ginawa kong example kanina sa aspirin, which is 2.97. Okay? So sabi ko kanina, di ba, pKa ni aspirin is 2.97. If exposed to a pH of 2.97 din, ang mangyayari class, complete dissociation of the ions, negative and positive. Kaya class, the drug will exist 50% ionized and 50% non-ionized. Okay? So are we clear? Ionized, sabi natin, complete dissociation na to. Okay, equals, quits. Okay, quits yung pag-dissociate niya into its ionized and unionized species. Right? So the Henderson-Hasselbalch equation class is one of the equations that expresses this dissociation clearly, or it's the equation, okay, that shows the dissociation clearly. So class, ang sabi lang naman dito kasi is, ang formula for weak acid, iba class ang formula ng weak acid, iba ang sa weak base. I'll show you the difference. Okay? Sabi dito, pH equals to pKa plus log ionized over unionized. Mamaya class, makikita nyo, pag discuss ko to, pag nag-compute tayo ng mga buffers, instead of using ionized class, I'll be using the terms conjugate base and acid. Okay? Pero I'm referring lang class to unionized and ionized at the same time. Pareho lang yun. Alright? Kaya ko lang siya papalitan mamaya class. Ini-inform ko na kayo mamaya. Pag nag-start na ako mag-discuss ng buffer, okay, ito yung mga ilalagay kong terms. Conjugate base and acids. Kasi class, ang gagawin natin dito is magko-combine tayo ng mga acids and a conjugate base. Let's say for example, acetate and acetic acid. Acetic acid class is the acid, obviously. Acetate, ang chemical ko na acetate is my conjugate base. Okay? Tapos titingnan ko na lang how much acetic acid should I put, how much acetate to create a buffer solution whose pH is, kung ano man ibibigay ko dito, kung ano man kailangan kong pH. Okay? Right? So, mamaya pag-usapan natin yan. Pero ulitin ko lang, for now, kasi extent of ionization ang pinag-uusapan natin dito. Okay? So, ang gamitin natin terms class is ionized versus unionized. Pero again, mamaya papalitan ko yan, conjugate base and acid, or conjugate acid and base. Okay? Okay. Tingnan nyo to class ha. Tingnan nyo to. Itong formula na to. Look at the relationships. Right? How is pH related to the ionized and unionized species of a weak acid drug? If I increase the pH class, if I increase the pH of my solution, tandaan yung solution yan, ano nangyayari sa solution ko? Nagiging acid or nagiging base?
Nagiging base po.
Very good. Nagiging base, right? So it becomes more base. Now, dahil weak acid ito, yan. It's a weak acid, right? So dahil nagiging basic ang aking solution, anong mabubuo ko? Salt, ionized or unionized species?
Ionized po.
Ionized. Very good. Tama? Kaya class nasa numerator si ionized. Kaya nasa numerator dito si ionized. Ito. Kaya siya nasa numerator. Ibig sabihin, if a weak acid is exposed to a solution whose pH is high, then majority of that drug will exist in its conjugate base form. Or majority of that drug will exist in its ionized state. Bababa yung unionized or acid form ng gamot. Are we clear? Does that make sense? Okay. Now, ang next question dito, class, is, sir, how high is high? Para masabi kong nagiging basic na yung aking solution. Normally, class, when we say basic ang solution, di ba sinasabi ko lang dyan, basta pH higher than 7, right? Any pH higher than 7 is considered to be basic, right? Okay. Class, applicable lang yan para sa tubig. Okay? If we're only considering water here. It's only applicable to water. Where in water, the neutral pH of water is 7. Right? Now, class, once we're considering na Henderson-Hasselbalch equation, ang titingnan natin dito, class, is pKa. pKa. pKa, class, again, is the dissociation constant that is specific to your drug. Ibig sabihin, class, ang neutral pH ng isang gamot o ng isang substance is dependent on its pKa. Again, balikan ko example kanina, aspirin. Si aspirin class, 2.97 ang pKa. Now, sulat ko dito, kunwari, palitan ko lang yung, yung ink natin. Okay. So, ang pKa niya, class, is 2.97. Ang ibig sabihin niyan, class, any solution whose pH is higher than 2.97 is already basic for aspirin. Does that make sense? Halimbawa, class, ang pH ng solution ko is 4. pH of the solution. Kung saan ma-expose yung acid ko, yung aspirin ko, yung aspirin, tama. Okay? Ang pH niya is 4. Now, class, dahil 4 ang pH ng aspirin, ang 4 ang pH ng solution, pag in-expose ko si aspirin dyan, anong i-expect ko kay aspirin? Will it exist in its ionized or unionized state?
Unionized po.
Ionized or unionized? Sorry?
Unionized po.
Unionized? Actually, no. Bakit? Bakit? Technically, titignan ko, di ba? 4 is technically acid, right? Technically acid. No? Pero, anong sabi ko kanina? For a drug class, ang pKa yung kanyang pinaka-neutral pH. Para sa isang gamot, ang pKa niya is neutral pH. Anything higher than 2.97, halimbawa, ito pKa. Anything higher than the drug's pKa is basic. Anything below the pKa is acid. Para lang sa gamot na yun, ha? Para lang sa specific na gamot na yun. Make sense? So, halimbawa, class, may gamot ako, drug X. Kunwari, ang pKa niya is 5.4. Okay, 5.4. Huwag na lang 5.4. Gawin natin 8.4. Kunwari lang, 8.4 ang pKa niya. So, class, pag in-expose ko to sa water, whose pH is 7, para sa drug X, para kay drug X, whose pKa is 8.4, ano si water? Acid or base? Para lang kay drug X.
Acid po.
Very good. Para kay drug X, acid na si water. Acidic na si water para sa kanya. So therefore, if I expose drug X, which is a base, sabi natin weak base to, whose pKa is 8.4, i-expose ko sa water, anong mangyayari sa drug X ko? Will it exist in its ionized or unionized?
Unionized po, sir.
Unionized po.
Unionized? Okay, tingnan nyo to, ha. Drug X is a weak base. Weak base. Water, whose pH is 7 ang water ni pH, is acid para kay drug X. Tama? Acid na si water para sa kanya. So, si weak base, okay, whose pKa is 8.4, was exposed to water, who has a pH of 7, which is already acidic for him, ano mangyayari sa kanila? Acid and a base, you form?
Ionized po.
Yes, you form a salt, which is ionized, which is water soluble, which is sabi natin, may excrete sa loob ng katawan ko. Naintindihan niyo ba? Isa pa example. O, balikan natin si aspirin. Balikan natin si aspirin, class. Aspirin has a pKa of 2.97. Okay? Aspirin is a weak acid. Right? Weak acid si aspirin. In-expose ko siya, class, sa isang solution whose pH is 4. Question. Okay, bago i-drop yung pinaka-main question natin. For aspirin, class, the solution is what? Acid or base?
Base po.
Very good. The solution is base. Now, pinag-combine ko si aspirin at saka yung solution na pH 4. Anong mangyayari sa kanya? Ionized, unionized?
Unionized po, sir.
Ionized po.
Very good. Okay, so class, a solution of 4, exposing aspirin to that, will create more ionized species. Okay, ibig sabihin yung aspirin ko will exist mostly in its ionized state. Right? It will exist mostly in its conjugate base form. Are we clear? So ano expected ko ngayon sa kanya? Ma-absorb, ma-excrete? Majority will be ionized?
Ma-excrete po.
Okay. Expectations ko dyan, class, majority of that will be excreted. Does that make sense? Sige, ulitin natin. Sa example. Okay, okay magala. Class, this is one topic na gustong-gusto kong naiintindihan ng mga estudyante ko. Kasi once naiintindihan nyo na to, mga computations natin mamaya mas madali na lang eh. Okay? Okay, magala, mas i-review nyo ulit to sa BioFar. Okay? Pero at least alam nyo na to. Mas more on application yung question sa biopharmaceutics in terms of sa katawan na. Okay? Say for example, aspirin ulit, gamitan natin aspirin. Okay, siya alam na natin yung pKa niya eh. So aspirin pKa is 2.97. Aspirin. So alam niyo naman, di ba, aspirin is a weak acid. Right? Okay? So at least alam niyo yan. Sabihin natin, class, aspirin was exposed to blood. Whose pH is equal to 7.4. Standard yan. Alright? Now, class, anong in-expect kong mangyayari sa aspirin ko? Will it be absorbed or will it be excreted? Ito na lang muna, bago yan. Okay. What will happen to my aspirin if it's exposed to blood? Will it exist in its ionized state or unionized state?
Ionized.
Ionized po.
Very good. It's going to exist in its ionized state. Anong expected ko ngayon sa aking aspirin? Absorb or excrete?
Excrete.
Excrete po.
Good. Excrete. Okay? Expect ko nang ma-excrete siya. Right? So sige, wait lang. Check ko nga ano ba ang pKa ni morphine. Okay, 8. Depende pala kung anong klaseng morphine. 8.08. Okay? So, sulat tayo ng space. Morphine pKa is 8.08. Makes sense. Basic kasi si morphine eh. Okay? Now, say for example, class, morphine. Morphine was exposed to a solution. Whose pH is 9. pH ng solution ko is 9. Morphine ko, ang pKa niya is 8. Okay? What will happen, class, to morphine? Will it be existing its ionized state or unionized state?
Ionize, sir.
Ionize. Ionize? Ionize. Okay. Tandaan nyo to, ha? Alright, tandaan nyo to. Kakasabi ko lang, morphine is a weak base. Weak base. Ang kanyang pKa is 8.08. Sabi ko sa inyo, class, pag pinag-uusapan natin kung magiging ionized or unionized ang isang gamot, titingnan nyo lagi yung kanyang pKa. Ano ba ang pKa ng gamot na yan? 8.08. Meaning, anything higher than 8.08, ano para kay morphine?
Basic.
Para kay basic. Okay. Anything lower than 8.08, like 7, 6, 5, para sa kanya,
Acid.
Acid.
Very good. Acid. Now, ang solution ng pH ko is, ang pH ng solution ko is 9. Para kay morphine, ano na ito? Is it acid or basic?
Basic.
Basic po.
Basic. Very good. Basic siya. So now, in-expose ko si morphine, which is also a weak base. Anong mapo-form ko?
Unionized po.
Okay. Meaning, class, if I combine both of which, okay, my morphine with the solution, tunawin ko siya doon, ang mangyayari, class, is it's going to exist mostly in its unionized state. Meaning, it's going to exist in its free base form. Okay? Now, given that it's going to exist in its unionized state, ano expected ko? Absorb sa cell or
Absorb.
Absorb. Ma-absorb to. Does that make sense? Ganito, class, ha? Ang technique dyan, ganito lagi. Okay, titingnan mo para malaman mo kung ang pH ng solution mo is acid or basic para sa gamot mo, titingnan mo lagi ang pKa. Kaya ganun ka-importante, class, yung pKa na yan. Okay? Okay, mag-alala, standard naman ng pKa sa bawat specific compounds eh. Okay? Basta tingnan nyo yung pKa, tapos yun ang magiging benchmark mo. Okay? Anything above that pKa is basic. Anything below that pKa is acid. Alright? Ang next na dapat, ang pangalawa, so yun, una tingnan mo ang pKa. Pangalawa, class, tingnan mo kung ano yung gamot mo. Is it a weak acid or a weak base? Okay? Para malaman mo na ay, weak base ang gamot ko. So, pag lower yung pH ng solution, kung saan ko tutunawin yung gamot, so ganito lang naman yung class eh. Ito yung baso ko. Di ba may solution yan? May solvent. Ano ang pH ng solvent na to? Tapos meron akong gamot. Say for example, aspirin. Ang titignan naman dyan is, ano ang pKa ng aspirin ko? Di ba pag tinunaw ko siya dyan, dahil weak electrolyte si aspirin, hindi yan magko-completely dissociate. Correct? Yun ang sinabi natin kanina. Hindi siya magko-completely dissociate. Kung sakali man mag-completely dissociate siya, dapat equal ang pH sa pKa. For it to undergo complete dissociation. Okay? Pero dahil most likely mahirap yung ma-achieve, saan mangyayari dito? So, ibig sabihin, aspirin will be partially ionized, partially unionized. Gets? Now, para malaman ko gaano ka-ionize yun, mamaya natin pag-usapan yun. Okay, pag nag-computation na tayo. Okay? So, how much ang mag-exist in its ionized state, how much will exist in its unionized state. Alright? Are we clear? Okay. So, class, ito yung formula ng acid. Tingnan nyo ha, anong pinagkaiba niya sa base. Ang sa base kasi, class, is pH equals pKa plus log unionized over ionized. So, mamaya, sabi ko lang dyan, base over conjugate acid. Anong napansin nyo, class? The difference between the formula for a weak base and a weak acid?
Yung numerator po.
Very good. Class, yung proportion, yung ratio na to. This one. Okay? yung ratio na to class between ionized and unionized, doon na siya magkakatalo. Kasi tingnan nyo to ha, pag tinaasan ko ang pH, magiging acid or base?
Base po.
Basic. Ano ang gamot ko? Weak base. So base ang solution ko, base din yung gamot ko, sino magdodom? Ano mangyayari sa kanya?
Unionized.
Unionized
Very
po.
good. Unionized. Kaya nasa numerator si unionized. Kanina si acids, sino nasa numerator niya? Ionized. Kasi habang nagiging more base, mas nagiging basic ang solution, yung gamot ko mas mag-i-exist in its ionized state. Okay? Kasi base, acid, ionized. Kaya sa numerator si ionized. Dito naman, okay, dahil nga weak base ito, so pag tumaas ang pH, mas magiging basic, so dahil base ang gamot ko, so magdo-dominate ang unionized portions ng gamot. Okay? Does that make sense? Okay. So, yun siya class. So, again, ang titingnan nyo lang dyan lagi, pKa. Babasihan yung pKa. Right? My God, 248 na pala. Mag-uumpisa pala ako ng pH calculations natin. Okay? Sige. Basta tapos ko muna ito class. Pagkatapos ng pH calculations, break tayo, then we'll proceed with buffer. Right? So, anyway, sorry. Before anything else, naintindihan ba to? Are we
Yes
good
po,
with it?
sir.
Kaya kasi ganyan to ha. Ang sabi dito, di ba? If pH for a weak base drug, if pH is higher than pKa, then it will exist relatively in its unionized, more lipid-soluble form. Okay? That's why weak base drugs are said to be more absorbed in small intestines. Kasi si intestines is basic. Tapos weak base ang drug ko. So base, unionized, absorb. Make sense? Okay. So sige, last ano. Aspirin ulit, 2.97 pKa. Okay? Aspirin. Its pKa is 2.97. Okay? In-expose ko siya sa GI mucosa. Kunwari lang to kunwari lang. Ba't pa ako nagkukunwari? Pwede ka ma-search. pKa of GI mucosa. pH pa, sorry, pH. pH of GI mucosa. The average pH of the okay, 5.7. It drops to 5.7. Okay, pwede na yan. Sige, ang GI mucosa ko, oops, is 5.7, sorry. 5.7. Okay? If I expose class my aspirin in the GI mucosa, whose pH is 5.7, okay, majority of my drug will exist in its what form? Ionized or unionized?
Ionized po.
Unionized.
Then it's ionized, unionized.
Unionized.
May nagsabing unionized? May nagsabing ionized, Mr. Reyes?
Ionized po.
Ionized po, sir.
Very good. Okay, class, if exposed here, it's mostly going to exist in its ionized state. Kasi aspirin, again, is a
Weak acid.
Weak acid.
very good. Weak acid. Now, class, although technically acid din naman ang GI mucosa, right? Acid din naman. 5 points. Kaya lang, class, for aspirin, a pH of 5.7 is still not enough for it to exist mostly in its unionized state. Kasi for aspirin, ang GI mucosa is already basic. Are we clear? So majority, I'm not saying all of the aspirin will exist in its ionized state. Majority lang. Okay, most of it will exist in its ionized state. All right? Now, class, if we want the actual amount, you have to compute for this na. Okay, how much of the aspirin will exist in its ionized and unionized states, or in its conjugate base and conjugate base and acid forms? Are we good? Okay. Now let's talk about class pH calculations. So sawang-sawa na kayo dito, di ba? It's the power of hydrogen. And class, once you compute for this, isang formula lang naman lagi tatandaan nyo dyan eh. pH equals negative log and then the hydronium concentration. Okay? The concentration of your hydrogen ions. Now, normally class, ang concentration ng hydrogen ions is usually expressed in molarities. Sorry, molarity. Ano ba? Molarity. Moles per liter solution. Okay? Usually, expression nito is in molarities. Are we clear? Very good. Yung concentration ng hydrogen ions nyo, or hydronium ions. Now, sabi natin, pH is commonly expressed as negative log, H. Now, ito nga pala class, ang kadalasan ng pagkakamali ng majority ng mga estudyante. Ano ko nung ginagawa? Pag nakakita ng negative log, ina-antilog nila. I don't know if you do that. Okay? I had a lot of students doing that before. Tandaan nyo, sa pH class, it's negative log. Okay? Negative log. So, ibig sabihin, negative sign, tapos log. Are we clear? To compete for pH. So, acids have high hydronium ions, obviously, thus resulting to a low pH, while bases, on the other hand, have low hydronium ions, thus having higher pH. And most of the time, class, pure water has a hydronium ion of 10 to the negative 7. So, meaning ang pH niya is 7. Okay, pure water yun. At ang sinasabi natin, that's the neutral pH of water. Right? Okay. So some things that you have to remember here. Okay, the combination class of hydronium ions and hydroxyl ions would usually be equal to 1 times 10 to the negative 14. So hence class, if I express this as pH, pH class is the power of hydrogen, and POH obviously is the power of hydroxyl. Very good. Okay. So class, si hydroxyl, saan to common? Acids or bases?
Bases po.
Okay, so si base ang meron ng hydroxyl ions. Okay, pero oftentimes class, mapa-acid or mapa-base, pH pa rin naman tinitingnan natin eh. Okay, titingnan natin kung mataas ba ang pH or mababa ang pH. Okay, now class, just so you know, the combination of your pH plus POH should always be equal to 14. Okay, yan yung general formula. Right, so whatever, kasi di ba ang maximum range lang naman kasi ng pH natin is 14, right? Okay, so yun lang naman maximum range nun. So again, pH class is defined as negative log, where hydronium ion is the concentration of protons in a solution. Right? And that protons, that concentration class of protons in a solution is often expressed in molarity. Okay, again, moles per liter. Are we good? Okay. So basta tandaan nyo ang hydronium ions natin, okay, will always be expressed in the concentrations of moles per liter, or molarity. Now, another thing, class, that you have to look at here is the formula for dissociation constant. Okay, ang dissociation constant natin, class, sabi nga natin, di ba, you need here, an acid or a base, either of the two, will always dissociate into its respective ions. Correct? Once exposed in water. Kung strong electrolyte yan, complete dissociation yan. Okay? Pero kung hindi yan, kung hindi siya ganun kalakas, okay, then class, the dissociation, of course, would vary. Okay? If it's a weak electrolyte, it's going to vary. So, class, ang usual formula for a Ka, okay, would be the ions, okay, how much has separated, either the conjugate base and the acid. Okay, ito yung conjugate base, acid over the acid, or the, what's it called, the substance na ginamit mo. Okay? We're good so far? The concentrations to, Okay, so again, class, when you compute for Ka, most often than not, concentration, this is the concentration of the acid. Ito yung concentration ng conjugate base. Kasi sabi natin, ang acid mo, once exposed to water, will separate into its hydronium ion, or hydrogen ions. Okay, ito yung H+, or ayan na pala, H+ na kasulat, or hydronium ions natin, and its conjugate base. Tandaan nyo, ang negative sign na yan would often indicate base. Okay, ito yung conjugate base ko. Tapos ito yung acid na ginamit ko. The acid that I use. Okay? Does that make sense, class? Ulitin ko Kasi di ba usually, class, kapag nag-undergo tayo ng reaction, an acid and a base, ito. Example to kasi ng weak acid If you combine an acid and a base, in this case, it's nitric acid combined with a base, which is water. Okay? It's going to separate, class, into its, talaga sinutin nga dito, conjugate acid, conjugate base Pero depende actually yan. Okay? So it's going to separate, class, into conjugate acid. So obviously, ito yung magiging base, or conjugate, or acid to its conjugate base. Alright? Does that make sense? Okay, basta ito acid, tapos yung kanyang conjugate base. Alright? Depende kasi kung anong gamit kong weak electrolyte. Is it an acid or a base? Okay? Basta anyway, class, whatever yung acid na ginamit mo dito, kung ano yung concentration yan, yun yung concentration na nakalagay sa ilalim. To compute for Ka. So, are we clear? Tandaan nyo ha, Ka pa lang to ha, hindi pa to pKa. Alright? Okay, Ka. Very good so far? Okay. Now, class, what about computing for Kb? Ang Kb naman, class, ginagamit ito for bases. Pero again, actually nowadays, class, we don't use Kb anymore. Kaya lahat puro Ka. Kasi i-express na siya as pH tapos. Okay? Pero anyway, Kb naman, class, on the other hand, is your conjugate acid. Ito yung conjugate acid. Ano paano ko nalaman na acid ito? Conjugate acid? What gave it away?
May positive sign.
Very good. Yun ang haabangan nyo lagi, class, ha? Kasi I swear, I never understood this when I was studying physical pharmacy before. Okay, mas sinabi sa amin ng teacher namin, ito ang base, itong acid. Sabi ko, dahil paano nalaman na yun ang base at yun ang acid? Okay? So, later in my life ko na na-realize na, yun pala yun. Hanapin mo lang yung positive at negative sign. Okay? Kasi class, kahit yung mga chemicals na gagamitin natin as a conjugate base and an acid, naka-indicate na yung charges nila. I-indicate lagi yung charge nila. So, para alam mo kung sino yung conjugate acid, sino yung base, or sino yung conjugate base at saka acid. Right? So, ito obviously, class, yung concentration ng hydronium ions ko. Okay? So, hydroxyl ions, concentrations of hydroxyl. Okay? And then, obviously, itong B na to would be yung base na ginamit ko. Concentration of the base. Are we clear? Very good. Pero class, again, sinasabi ko sa inyo, kadalasan hindi natin itong ginagamit. Okay? Kadalasan hindi natin ginagamit yung POH, Kb. Ang kadalasan na ginagamit natin is Ka. Right? Okay, ulitin ko. Ka, yan yun. Concentration ng iyong conjugate base plus yung acid niya divided by the concentration of the acid na ginamit nyo. Yung nag-dissociate. Okay? Are we good so far? Okay ba?
Yes po, sir.
Okay. Alright, good. So ito class kayo na, yung sa nitric acid, so maghiwala yung hydronium ions ko, hydrogen ions, saka yung nitrate, which is the conjugate acid, conjugate base. So yung conjugate base. So ano yung concentration nito? Concentration of the conjugate base, tapos concentration of my hydrogen ions, okay, divided by the concentration of nitric acid. HNO2 or HNO3. HNO2 pala. Okay? Yung aking acid dito kanina. So are we good? Okay. So now class, say for example, I'm given my Ka. Kailangan ko yung hydronium ions ko or hydrogen ions, concentration nito, pwede ako mag-transpose. Okay? I can just transpose my formula. Are we good? Okay. Basta provided ako na Ka. Okay? Yun. Are we good? Okay. Now, here lang class ha. Again, palatandaan lang, pag weak acid, kadalasan, weak acid or weak base, weak electrolyte in general, hindi class complete ang dissociation. Okay? That's why, again, it really depends on the pH of the solution where they are being dissolved in. Unlike that class of strong acids and strong bases, okay, they always undergo complete dissolution. So that's why class, most of the time, basta complete ang dissociation nila. Okay? Okay, so here are some formulas that we need to be reminded of. Okay, when you're computing for pH, that's just negative log of the hydrogen ions. Pag compute ng OH, negative log ng OH. So ano kasi napapansin nyo pag nilagyan mo ng P? Ang P na yan is always an indication of negative log. Okay? So are we good? Okay. Now class, if I'm going to get the other way around naman, halimbawa, kailangan ko ang hydrogen ions ko. Okay? Kailangan ko concentration ng hydrogen ions ko. Gusto ko malaman kung ano how much acid should I be putting in. Okay? So class, ang formula niyan is 1 divided by the antilog pH. Are we clear? Very good. So ano yung magiging pH ng solution mo? So, dun mo malaman kung ano yung concentration ng hydrogen ions mo. Same goes with hydroxyl ions. Okay, that's 1 over antilog POH. Right? And then sa Ka naman, ganun din. If you want to determine class Ka, that's just 1. So ano yan? 1 over antilog your pKa. So, are we good? Okay, kasi si pKa kanina, ang gusto makuha yan, kung kailangan ko si pKa, and then negative log Ka lang yan. So, are we good? Okay tayo, ha? Okay, so just remember din class, pH plus POH is equal to, pH plus POH is equal to, anong lalabas dapat dito? It's always,
PKA.
pH plus POH. pH plus POH is always 14. Kasi baka mamaya class, instead na pH ang ibigay ko sa inyo, magbibigay ako ng POH. Kunwari, trip ko. Gusto ko magbigay ng POH. Ano, papa-example ako. POH ang ilalagay ko. Pero pH ang kailangan ko. O, di ba? At isa lang yung paano siya i-change. So, ang gagawin mo lang dyan, pH equals 14 minus POH lang. Right? So, whatever your POH is, baka may maghanap ka pa, sir, asan ang Ka? Asan ang concentration ng hydrogen? Right? Nagets yung class? Right? Kaya kailangan maalala nyo yung mga to. Right? And another thing, class, before I forget nga pala, KW. KW madalas ginagamit for water, ha? Pero KW is just simply equal to, yun na nga, your Ka multiplied to your Kb. Okay? And usually, class, ang KW is equivalent to 1 times 10 to the negative 14. Okay? So, parang ito. So, di ba si pH plus POH is equal to 14. Dito naman, Ka times Kb is equivalent to 1 times 10 to the negative 14. Okay? Pero multiply yan, ha? So, are we good? So, sikat na sikat to. pH, hindi nyo pa nga pa nakikita to. Okay? Madalas kasi ginagamit natin ng pH meter to calibrate the pH of a substance or when we're computing for buffer capacity. Mamaya natin pag-usapan yun, ha? Okay, pero kasi ginagamit ito to measure the hydronium ions or the hydrogen ions present in a solution. Kaya notice kasi, wala tayong device that measures hydroxyl ions. Kaya kadalasan, imbis na gumamit ng POH, we express anything, acids or bases, as pH, based on their pH. Are we clear? Kasi madalas ang mini-measure lang natin is how much hydrogen ions are present in your solution. Okay? Any questions so far? Okay. So why is pH important? Sabi natin pH affects solubility of many substances. Masasabi natin kung water soluble or lipid soluble lang isang substance based on their pH, right? Provided I know the pKa. Correct? Pwede ko masabing it's going to exist in its ionized. It's going to exist in its unionized state. It's going to be lipid soluble or water soluble, blah, blah, blah. Okay, so pH affects the structure and function of most proteins, including enzymes. Okay, if the pH class is too basic, it tends to denature proteins. Okay, kumukulubot yung protein structure natin. And many cells and organisms can only survive in a specific pH environment. A good example of this class would be bacteria, say for example. Did you know, class, that majority of the bacteria in the genitalia exists in a basic environment? Kaya tingnan nyo, class, pag ang babae na alter ang pH ng kanilang vagina, class, nagiging more prone sila to yeast infections or any infections for that matter. Kaya tingnan nyo, ano yung feminine wash natin? Yung pH care. Ano ang pH nun? Hindi niya familiar? Yung pH care? Anong pH niya? It's pH 5.5. Okay? And 5 pH class is acidic or basic?
Acidic.
It's acidic because it's trying to keep the vaginal pH class acidic para hindi mag-grow ang mga bacteria. Okay? Are we clear? All right. Good. Okay? So yun. So many cells and organisms can only survive in specific pH environments, and most bacteria class can alter the pH of certain environment inside our body to to accommodate their growth. Yun na nga, like Candida halimbawa, it makes the vaginal pH class basic. Okay? Kaya nga 'di ba kadalasan din ng na home care remedy for any infection in the vagina class is acetic acid diluted. Right? Here's a sample problem class. Madali lang to. So what is the pH of a 0.05 molar solution of hydrochloric acid whose pH is 1.3? Now, suot mo given ko. Sige, suot natin given natin. Okay? May duma ang lakas ng speaker ng truck na yan. Okay, so ang given natin class is pH. Is equivalent to 1.3. Okay? Tapos, molarity ng solution or concentration is 0.05 molars. Now, class, here's the thing, ha? Here's the thing. Hydrochloric acid, is it a strong electrolyte? Is it a strong acid or a weak acid?
Strong acid po.
Very good. Okay, at least alam nyo. Right, this is a strong acid. Kaya mas importante rin na malaman niyo kung strong acid or weak acid ang inyong compound. Okay, you can always search for it class over the internet. Don't worry. Pero in my case, I'll always inform you guys kung strong acid or weak acid ang isang gamot ko. Okay? Now, strong acid ng hydrochloric acid, okay, we know that. Now, the thing is class, kapag strong acid or strong base ang iyong gagamiting compound here, okay, whatever the concentration of your strong acid is, ito na rin kasi class ang magiging concentration ng hydronium ions mo. Okay? Provided again that it's a strong acid. Right? So ulitin ko whatever is the concentration of the strong acid, yun na rin yung concentration ng hydrogen ions niya. Are we clear? Meaning that's the same amount of protons it's expressing. It's going to express. Kasi nga, mag-undergo siya ng complete dissociation. Kasi strong acid, strong electrolyte siya, strong acid siya, strong base. Maliwanag tayo? So therefore, class, a 0.05 molar solution of hydrochloric acid will actually give a hydrogen ion concentration of 0.05 molarity as well. Are we clear? So yun na isusulat ko. Hindi na ako magpapakahirap. Okay? Ay, ba't ko sinulat pa pH? Tinatanong ang pH yan, Ben. Sinulat ko na agad yung sagot. Okay? Pero ang pH na dapat is 1.3, okay? So, ang binigay sa akin is the concentration of my HCl, molarity of HCl. So, how did I solve for this? So, required is pH equals unknown. So, ang solution niya, class, di ba sabi natin, pH is just simply negative log hydrogen concentrations mo. So, negative log 0.05. Again, class, it should always be expressed in molarities. Okay, negative log 0.05. You get a pH of, pareho ba tayo? 1.3010 or 1.3. Take note that pH has no units. Okay? Are we good?
Yes,
Are we
po,
clear?
sir.
Okay. Magiging complicated to class pag weak electrolytes na tayo. I'm just informing you guys right now. Okay, right now it's so easy, right? Yan lang pala yun. So, negative log H ng plaka. So, kung ano yung concentration ng yun na yun. Okay? Alright. So, are we good? Natandaan nyo class, laging hydrogen ions ang hinahanap natin dito. We rarely look for hydroxyl ions. Kasi nga, ang pH meter ko, ano bang ginagamit, ano bang minimeasure niya? It measures the total amount of hydrogen ions in my solution. Kaya kadalasan, laging hydrogen ions ang gagamitin natin dito. Okay? So, ito lang naman ka solution dyan. So, here's the solution. What about this one? Excuse me. Though rare na ginagawa to, pero pwede natin gawin. You are presented with a solution that has a pOH of 2.13. What is the pH of the solution? Right? Sabi ko, rare to ginagawa, pero balay nyo, makakita kayo ng mga problems na ganito. Ang pOH niya is 2.13. The question is, what's the pH? So again, ang given natin is power of hydroxyl is 2.3. Ang required pH. Ano solution ko dito?
14 minus POH po, sir.
Good. Di ba, class, naalala nyo kanina? pH plus POH. Kaya sinabi ko to kanina is equal to 14. So, to get pH, that's just 14 minus 2.3 and you'll get 11.87. Make sense? Dali, di ba? Right. Siyempre, unahin talaga natin yung madali para hindi kayo madismaya agad. Hindi kayo ma-discourage. Okay, so ito lang naman yung class. So, yan. So, 14 minus POH, 11.87. Okay, ito class, in-explain lang dito kung paano nakuha yung pH plus POH equals 14. Alright? Pero ang solution ito lang naman. Next one. Sodium hydroxide is a strong base. Okay? What is the pH of 0.02 molars sodium hydroxide solution? Okay? So, ang pH daw dapat dyan would be 12.3. Right? So, how do we answer this? So, again, class, since this is already a, binigay na ang kanyang pH, ang kanyang concentration is 0.02 molars. So, obviously, class, I already have the hydrogen concentration ko. Okay? Nagkataon lang dito, it's a base. So, therefore, similar lang naman ang gagawin natin. Lang, 0.02. Okay. Ay, sorry, mali. Tama ba? Wait lang ha. Just making sure. Okay nga pala, POH nga pala makukuha ko dito. Okay, so sorry about that. So this still class. So this one's a base. Okay? So ang mangyayari dito class, since it's a base, it's gonna be a strong base, ang kanyang ipoproduce would be mostly OH. Correct? Okay, majority na ipoproduce would be OH. So therefore class, similar to acids, wherein whatever yung concentration niya, yun na yung H concentration ko. Okay? Same thing lang naman dito class, pero makukuha ko dito is OH. So ang gagawin lang natin is, saan na ba dito? Given. Okay? Ang concentration ko, concentration of sodium hydroxide is equal to 0.02 molar. So obviously class, sabi ko sa'yo, dahil strong base ito, it's a strong electrolyte, so yung kanyang OH will just be the same, 0.02 molar. Okay? Because again class, this is a strong base. Kung strong acid, obviously, ang majority na ilalabas niya would be H. Correct? Hydrogen ions. Okay, so since majority ilalabas ito would be hydroxyl ions, so OH is equals 0.082. Now, obviously, class, I can compute directly for pH. Ang una kong i-compute, ang required dito would be pH equals unknown. So, ang solution na magagawa ko dito would be mag-POH muna ako, which is simply negative log OH. Again, kaya OH to class kasi, it's a strong base. So, negative log 0.02, ang lalabas is 1.69, 1.7. 1.70. Okay? The POH is 1.7. Now, of course, class, that's just POH. Anong gagawin ko next?
Minus 40.
Okay, pabalik tayo ngayon ulit doon. pH plus POH equals 14. Okay? So, therefore, pH is equal to 14 minus 1.7, and that would give you 12.3. Alright? Make sense? Okay. So, ito yan. So, sabi ko sa inyo, class, basta strong electrolyte, basta strong acid or strong base, whatever yung kanyang concentration, paano na ka mahirapan whatever yung concentration niya, yun na rin yung concentration ng hydroxyl ion or ng hydrogen ions, depende kung acid yan or base. In this case, it's a strong base. So, hydroxyl ions yung ipoproduce ko. Alright? Are we good? Okay. So naman, since it's a strong base, it makes sense that the pH is above 7. Here, class, let's have an example of a weak electrolyte. Okay? Ang sabi ko nga sa inyo, class, di ba? Ang problem with weak electrolytes is they do not completely dissociate. Okay? So whatever is the concentration of the original concentration of their solution, okay, hindi yun equal to the amount of hydrogen ions produced or the conjugate base na produce. Okay? So are we good? Okay. Before I proceed any further, right? A, B. Sino ang conjugate base? Is it A or B? In the equation that I have. Ay, ba't ako dyan nasulat dito pala? A or B? Sino ang conjugate base?
Si Florin po.
Very
A
good.
po.
A is ano. Right? This will be the conjugate base, while the hydronium ions class would be the acid. Okay? Some people would call this conjugate acid then, pero generally we just call it acid na lang. Okay? Now, class, this is hydrofluoric acid, which is a weak electrolyte, a weak acid. Okay? Now, class, ang reaction niya kasi, if it's combined with water, it tends to separate into ito na nga, ito yung conjugate base and its acid. Okay? Now, of course, each of this will have its own respective hydrogen concentrations. Now, kapag magko-compute tayo, class, ng Ka nito, di ba sabi natin, ang magiging formula would be Ka is equal to conjugate base, right? So it's conjugate base plus acid over yung yung acid talaga na gagamitin natin. Yung acid na ginamit natin, 2, which is separated. Right? So in this case, class, ano yung acid na ginamit natin? It's hydrofluoric acid. And the concentration of hydrofluoric acid is
0.04.
0.04.
Okay, very good. So, ang hydrofluoric acid ko is 0.04 molar. So, yun yung concentration na gagamitin ko dito. Okay? Now, I'm given the Ka value of my hydrofluoric acid. Ka ito, which is 7.2 times 10 to the negative 4. Okay? So, looking at this class, ang mangyayari is, wait, solve ko pala muna to. Ka is equal to 7.2 times 10 to the negative 4. So, dapat ang pH dito is 2.3. Now, kailangan ko dito, class, would be, di ba sabi natin, to compute for pH, it's just negative log hydrogen ions mo. Okay? You need to compute for hydrogen ions. Right? Now, right now, class, I don't think I have the concentration for my hydrogen ions. But I do have the concentration of the acid that I use. Okay? Kasi hindi ko to pwedeng gamitin as my hydrogen concentration because hydrofluoric acid is a weak electrolyte. It's not going to completely dissociate. So to compute for that class, ang gagawin ko, I'm going to use the formula of Ka. Okay, mamanipulate natin yan. So now, class, di ba meron tayong conjugate base and an acid, all of which contains hydronium ions, correct? Hydrogen ions. Yung conjugate base, may hydrogen ions yun eh. Di ba may matitirang hydrogen ions doon? Nag-donate lang siya ng protons. Okay? Tapos yung aking acid. So, ang mangyayari dyan, class, is Ka equals, so dahil hindi ko alam yung hydrogen ions niya ngayon, I'll put a representation of X muna. Okay? For the conjugate base, tapos another X for my acid. So, this again, conjugate base, andito yung acid. Right? Kasi diba F times hydronium ion. Tapos over HF. Hydrofluoric acid, which is yung may concentration ako for hydrofluoric acid. Okay, which is equivalent to 0.04. Now, mayroon akong Ka, so gagawin ko ganito. 7.2 times 10 to the negative 4 equals, kasi pareho lang naman silang X, so magiging X squared ito. Okay, as a variable. I'm just writing it, class, as a variable, ha? Okay? So, magiging X squared siya. Hydrogen ion ng conjugate base plus hydrogen ion ng acid ko. Okay, yung combination nila. Tapos, ang concentration na yun. Then, 0.04 molars here. Okay? Now, cross-multiply. X squared is equal to 7.2 times 10 to the negative 4 times 0.04 molar. Okay? Tapos, isa-square root ko to. Para makuha ko yung square root both sides of the equation. So, x would be equal to 7.2 exponent negative 4 times 0.04. Okay, square root of the answer would give me 5.37 na lang times 10 to the negative 3 molar for my hydrogen ions. Okay. Now, to compute for pH, sabi natin, negative log, hydrogen ion lang yun. So, negative log, ay putex ln ang sugupindot ko. Answer. You get 2.27. Are we good? Ayos ba tayo, class?
Yes po, sir.
Ayos. Okay. So, class, this is of course applicable for an acid. Okay? What if I use a base? Anong lalabas dito? H ba? Ang kakompute ko? Kumari, weak base to.
OH eh.
OH. OH naman ito. So, are we good? Okay. So, ito class, this is H equals. Sa H yan. Hindi na kasya sa, yung sulatan ko. So, that's H. Yung X na to, okay? Does that make sense? Okay tayo. Lagi yung tandaan class, pag pinompute ka ng pH, alamin mo lang yung H. Hydrogen concentration. Again, pag strong electrolyte yan, whatever is the concentration of your acid and base, yun na yun. Wala ka nang babaguhin. Kung strong acid yun, yun na yung concentration ng hydrogen ions. Pag strong base, yun na yung concentration din ng hydroxyl ions. Alright? Pero pag weak electrolyte class, you have to do this one. Are we good? Okay, good. So, yeah, ito yung solution dyan, class. Okay? Huwag natin, sa'yo na yun. Right? Ang sinabi lang dito kasi dapat may X pa dito may number of hydrogen pa Pero we can disregard that number since it's gonna be very small na hindi na significant yung magiging effect niya dun sa equation. So, tinatanggal na lang yung X dito sa ilalim. Okay? Okay, what about this one? What is the pH of, what is the pH of 0.02 molar ammonia solution if its Kb value is 1.8 times 10 to the negative 5. Okay, now this time naman class, Ka ginamit natin for acids, dissociation constant ng acid. Okay, Kb on the other hand, dissociation constant for bases. Okay, mixes naman, di ba? Ka, Kb. Okay, acid, base. Now, here class, ang example naman natin ngayon is a base. Okay? So here we have a base. Ito yung ating equation. So similarly, how do we proceed with this? Okay? So pretty much class the same thing. Okay? Yung ginawa natin kanina. So pero instead na H hydronium ions ang makukuha natin, we will be getting hydroxyl ions. Right? So ang given ulit natin would be ano ba yun? Concentration of ammonia is equal to 0.02 molar. Again, class, this is a weak base. Ang Kb is equivalent to 1.8 times 10 to the negative 5, or the dissociation constant of this base. Solution natin dito would be, required pH equals unknown. Technically, alam ko na, pero compute natin yon. So, first things first, class, compute for OH. OH natin. So, gagamitin natin, class, ang formula ni Kb. Which is equivalent to OH, okay, times ang ating ammonia, NH4. Okay. So, your conjugate acid over its base over NH3. Now, sabi natin class, gagawin natin dito, X na lang yan. Hindi ko alam kung gaano karaming hydroxyl ions ang ilalabas niya. Pero alam ko yung sa ammonia solution ko, which is 0.02. And my Kb is equal to 1.8 times 10 to the negative 5. Okay? So again, class, cross-multiply na lang. X squared equals 1.8 times 10 to the negative 5 times 0.02. Right? Get the square root of that. One point eight exponent negative 5 times 0.02 equals square root of the answer equals 6 times 10 to the negative 4. Okay, so this is the amount of OH. This is the concentration of your hydroxyl ions. 6 times 10 to the negative 4 molarity. Of course, di pa tayo tapos dyan kasi kailangan ko dito is pH. So obviously, class, using OH, I'll be getting POH, correct? So that's negative log OH. Negative log 6 times 10 to the negative 4. Okay. Negative log answer. You get 3.22. Okay, pH, sabi nga natin, is 14 minus POH. 14 minus 3.22. You get 10.77, ayan, 78. Or sabihin natin 10.8. Okay, if rounded off. Right? 78 ba ito? Okay. So are we good, class? Are we clear? Okay, make
Yes po,
sense?
sir.
Mag-ingat lang kayo, class, sa magagamitin yung pKa, kung pH ba, kung H ba kinocompute nyo or OH, doon na kayo kailangan mag-ingat. So tandaan nyo lang, pag base yan, kadalasan that's OH. Okay, pag yan ay acid, that's H. Okay, hydronium ion, hydrogen ions. Right? Okay, what about this one? Maganda to. A sample of gastric juice has a pH of 2.5. What is the hydrogen ion concentrations in this secretion? Okay? Madaling-madali lang to, class. How do I answer this? So, di ba sabi natin kanina, so kung yung given ko pala. Ano ang given ko dito? I have pH which is equal to 2.5. Ang required sa akin is yung hydrogen ion concentration, which is unknown. Correct? So, anong formula ang gagamitin ko dito, class?
1 over antilog.
Very good. Alright, very good. So, class, madali lang to. As long as I'm given the pH nung substance ko. Okay? Kasi binigay na dito yung substance eh. Tapos tatanungin nila kung anong pH, anong hydronium ions nun. So, madali na lang yun. So, sabi natin, class, di ba? H is equal to 1 divided by antilog pH. That's just simply, actually, tinranspose ko na lahat ng pwedeng i-transpose na formula para sa inyo. Para sasalpak nyo na lang yung mga data natin. Right? Sabi ko, parang pag hinahayaan ko kayo minsan mag-transpose, minsan nagkakamali eh. So that's antilog of 2.5 equals 1 divided by answer equals, so give you 3.16 times 10 to the negative 3 molar. Okay? So, okay ba tayo? Alright, so technically, class, this is just the same na naman. Okay, ang mangyayari dyan is H equals 0.00316 molar. Okie-dokes. Alright. Ito, mas nagpakahirap siya eh, pero we arrive at the same solution naman. Okay? Okay. What about this one? An arterial blood sample from a patient has a pH of 7.4. 1 day later, the same patient has an arterial blood pH of 7.15. How many times more acidic is the patient's blood on the second day? Okay, now take note of this class. We're looking at the acidity. When we're measuring acidity class, anong kinocompute ko dito? Hydrogen ions or hydroxyl ions?
Hydrogen ions po.
Definitely class, I'm going to base the acidity, how many folds increase ito based on the hydrogen ions na po-produce ko. Kasi again, ang marka class ng acidity ng isang bagay is based on the amount of hydrogen being released in the solution. Okay? If I'm going to check for its basicity, pwede pa rin naman ang number of hydrogen. Kasi kung konti yung number of hydrogen, di tataas ang pH. Pwede rin naman yun. Okay, pero kadalasan ginagamit is pOH. So in this case, class, we're going to check now how many times higher ang pH ng blood ng ang pH ng blood ng patient. So it started daw with 7.4. Tapos ang kanyang pH naging 7.15 after 1 day. So ibig sabihin mas naging acidic, correct? It became more acidic. So again, the question is how many times more acidic ba 'yon? So therefore, compute mo natin class ang hydrogen ions of each. Okay? So ang original blood would be pH equals 7.4. Right? So this one's the first one. So sabi nga natin, H equals 1 divided by antilog 7.4. It's going to be antilog 7.4. 1 divided by answer. 3.98 times 10 negative 8. Negative 8 molarity. Plus yung pH naging 7.15 antilog 7.15. Antilog 7.15 equals 1 divided by answer. 7.08 times 10 to the negative 8 molar. Okay? So, ang gagawin lang dyan, class, is tignan natin how many times higher siya. So, therefore, class, yung hydrogen ions nung second take, di-divide lang natin sa hydrogen ions nung first take. Okay? That will simply be 7.08 times 10 to the negative 8 divided by 3.98 times 10 to the negative 8. That will give you 3.98 exponent negative 8. It's gonna be 1.70. Okay? So the acidity class, the amount of hydrogen ions in the blood increased by 1.78 times. Okay? Walang units to, syempre. Pero ina-assess lang natin dito, class, how gaano kataas yung acidity, how much ang itinaas ng acidity ng blood from 7.4 to 7.15. Okay? Are we clear with that? Again, guys, I'm assessing here yung acidity. Gaano kataas yung acidity na in-increase. So obviously, dahil tumaas yung acidity, tumaas yung hydrogen ion concentration. Okay? Eh, syempre, hindi ko naman pwede gamitin ng pH dyan. Okay? Because that's just pH. Alright? Okay. So, yun siya. Next one. Calculate the pH of the following solution at 25 degrees Celsius. Okay? Ang kanyang OH hydroxyl ions would be 1 times 10 to the negative 5 molarity. Okay? So again, ginawa na rin naman natin ito kanina, right? Papakita ko pa ba? Nagets nyo na rin mang gagawin natin dito. Okay, pakita ko na lang. Just to be on the safe side. Alright? So sabi nga natin, class, di ba? I'm given OH. OH, is equal to 1 times 10 to the negative 5 molarity. So therefore, if I want to compute for pH, was unknown. Okay, kunin ko muna yung POH ko, which is negative log OH. 1 times 10 to negative 5. Negative log 1 exponent negative 5. Still 5. So my POH is 5. So therefore, if I want to get a pH, pH equals 14 minus POH. That's 14 minus 5, you get 9.